Okay, I think the clock is officially 20 minutes before noon, so let's get started. Just a quick raise of hands. How many of you are Blazor developers sort of in anger on a day-to-day basis? Okay, good amount of you guys. All right, so this session is about Blazor testing from A to Z, and before we get to that, let me present myself. I'm Egil Hansen, Dane, with a Norwegian name, and I live in Iceland. I also work for a company called Delegate. We're sort of a consultancy company, and my particular role is building cloud-native solutions on Asia mostly. I'm also a Microsoft MVP, and I became an MVP because I built a bunch of open source libraries. So that's also an option if you want to, join the ranks of the MVPs. So Blazor testing. Well, what we will cover today is, I guess, what I would like to call browser-driven testing. It might be called end-to-end testing as well, but that's really up to you if you want to go all the way to the end of your application or not. Browser-driven testing means that we take a browser, we open up our web app in that, and then we use code to drive the browser to do things on our behalf. So we automate that. And the second part, we will look at component testing. And component testing or unit testing is where we test our Blazor components in isolation from the rest of the application. And then sort of we will round out with a discussion of what options we've looked at and what the pros and cons of each of them are, and sort of take a look at what would you want to pick depending on your situation. So hopefully you will be left with a good starting point if you want to start testing your Blazor applications or Blazor components at home. So let's start with the first thing. So browser-driven testing. And for that, we will use Playwright. So Playwright is probably the most predominant UI testing library right now, browser automation testing library. It learned a lot from its predecessors, Selenium and others, that had a bunch of issues that made it hard to actually write good tests using those. And they've really focused a lot on having really good developer experience. Also having things around automatic retry, waiting for elements to show up on the page. They have good query APIs that you can use to talk or find elements on the web page that you want to interact with or do stuff with. So that really helps a lot. Another thing that really helps with Playwright versus some of the other alternatives are visual traces that you can capture during testing. So imagine you're running your test on a CI pipeline and things fail or something didn't go as planned. Well, you can have it capture the trace of the test, which includes screenshots, the DOM elements, the network traffic, all the things about the test, and you get it as a zip file, and you can replay that locally so you can sort of figure out what was going on, what actually happened. An important thing is that by default, you would run Playwright tests without the browser actually visually being shown, right? It's in a headless mode. So you don't see what's going on. So visual tracing really helps. Another thing that it can do for you is it can generate tests for you, or rather, it allows you to open up sort of a Playwright tool that will allow you to click around in your application and actually manually record what you want the test to do, fill out forms, click on buttons, navigate around. And then it'll capture that and generate the .NET code for you, or JavaScript, or other languages that Playwright supports. And you can sort of pull that into your test. So it makes it easy to create tests that are fairly complex, which is both a good and bad thing, but it certainly makes it easy to get started with Playwright and learn how to use the APIs in Playwright. I think it's well documented. It's not a given for open source libraries. And recently they added support for XUnit, which wasn't something that was there before. So I also had to change my entire presentation because I'm an XUnit kind of a guy. So now it's all the XUnit based. But there were some changes to XUnit that controlled how it did concurrency. So now you can actually have it minimize the amount of concurrent tests that are running together that are also asynchronous. And you'd imagine if you have maybe 1,000 Playwright tests and all of them are running concurrently, then that would maybe equate to spinning up 1,000 instances of Chrome. And we all know how much memory that uses, so that's probably not going to work on your CI pipeline. But with the new support in XUnit 2.8 to actually say that it should also limit the amount of concurrent processes that are running asynchronously or concurrent tests, that enables Playwright to work well with XUnit as well. Now, there is some small downsides to Playwright. Well, at least something to be aware of. So Playwright is something that comes out of Microsoft, and it comes out from a team focused very much on front end, so JavaScript, C#, or C# is more a second-class citizen. So you might Google search or chat to some GPT of your choice about ways to do things, and it will suggest an API that doesn't exist yet in C# land. But it's catching up quite well, and they're good at sort of keeping them on par. Much of the tooling is VS Code-centric, so if you're a Visual Studio type of person like I am, then you might also have to drop down to the command line once in a while to get all the features you need. And one thing that you might have to be aware of is that compared to maybe doing API testing or other things, like you have to actually have your web app running on a public port on an IP address that the browser can get to. So that's something we need to do as well, and that's not something that Playwright comes with, but luckily we have few options in .NET already. We have the web application factory. How many of you have used that before? So you will know that web application factory is sort of a white box testing approach. We typically use that for API testing. It allows you to spin up your application in the test itself, and you can also change configurations or customize the web app that you're testing directly with Web Application Factory. So you have deep hooks into it, and you don't have to have extra things in your web application to support testing. A new thing that's new. Aspire's been around for about 2 years or so now, but you also have the option of using, if you have an Aspire-enabled web application, you can also spin up Aspire from your test and control Aspire, the Aspire app host from your test. But then it's more black box testing in a sense that your web app, the only sort of hooks you have to customize that for a testing scenario would be to maybe provide environment variables to it, maybe where you, for example, if you don't want to use the real database during testing, or you want to reset things along the way. So both approaches work. I've started using the second one at work, and it's quite nice that you spin up everything and you have sort of a full, it really gives you end-to-end testing in theory. But for this demo, we're just going to use Web Application Factory, but to enable it to actually do the thing, exposing the web app to a browser so we can interact with that, we need to hack it a little bit because it really is not built for that. So to understand what we need to do, well, if we look at the default way it works is that you basically take a Web Application Factory type, new that up, and point it at your web app you want to test. And then you can ask your Web Application Factory to give me a HTTP client that allows me to call that web app that you're testing directly. But it's all in process, in the same, in the scope of the test. So it's not exposed externally. And what we need is, well, instead of having our test code using HTTP client, we want our test code to use the Playwright to instrument a browser. And that browser should be able to connect to our test app. So what we want to do is we want to achieve a bunch of things. We want to have it instantiate and run our web app on 127.0.0.1 on a random port because your port might be used by other things. So we wanted to pick a port at random when it starts up. And then we also wanted to support HTTPS and other things. So I figured out a way to do it. The reason why I call it a hack is it's not super pretty, but it works, and it's quite stable. And by the way, all the code that we're going to look at today is going to be shared on a GitHub repository, so you can go and download it and sort of take that bit out if you want to do the same thing. Now, before we get into the actual code, I just want to show you how I set up my test solution. So you can repeat that at home if you want. So what we have is we have a just standard Blazor.NET 9 app. We have a XUnit test project, and then we have a solution file, and we've added both the projects to the solution file. Then we want to make some modifications to the test project. So we add a reference to the system under test, the app we want to test, to our test project. We add Playwright, because we need that. We add this package from Microsoft, ASP.NET Core MVC testing, which does have the Web Application Factory that we will need to spin up our web app during testing. And finally, because we also want to talk a bit about snapshot testing, we add some of the verify extension packages for XUnit, Playwright, and AngleSharp that we can use to do snapshot testing, which is quite valuable for these types of applications. And obviously, we have to end up with a .NET build, and the reason why we do that is because Playwright, the Playwright package will output a PS1 file in our bin folder, and after we have that, we can call that file and pass install to it, and that will install Playwright-specific browsers on our system so that we can use that for testing. And we use those instead of our whatever browser you have installed on your system, so that you can also test with Safari or Edge or Chromium or whatever you have. But you also have browsers that don't have all your customizations, all your bookmarks, all your cookies, and all of that. So you get a clean sort of environment to test it. Now, let's jump into Visual Studio Code and have a look at how this will work. Let's see if I can jump out of this. Maybe go to duplicate. There we go. And let's jump into the first test. Let me just double check that font size is okay for you guys in the back. I see some thumbs up, no protests. Okay, so it's not really, well, it might be interesting, and I can show you that afterwards if somebody want to see, but I've created a type called Blazor, a web application factory. It encapsulates all the hackiness we need to be able to spin up our web app in a public facing or something that we can access from a browser. So that's sort of packaged in there, and we just call start async on that. And actually, let's just briefly have a look at the web app first to see. Let me just spin that up. So as you can see, I'm very creative. This is the standard Hello World Blazor app you get out of the box. We do have a custom component that we can use to showcase some testing scenarios with. And this is a Blazor, a Bootstrap rather, alert component that you can dismiss by clicking that. Then we have the asynchronously loading weather forecast app. You can see when I click it here, it sort of loads a bit and then it gets some data. And then we have the counter components that everybody probably have seen a million times, where you click the click me button and the count increments. So if we start by going back to our test, we can write a test for this particular thing. And the test would be that, yeah, we want to see that count increments when we click the button. Now, we need a bunch of things in Playwright to be able to actually get to that point. So first off, we need the host running. We need our web app running, which is covered by this bit here. And then we need to spin up Playwright. In this particular case, I'm going to use Chromium as my browser of choice, but you could also ask Playwright to use other browsers or use all of them if you want to do that. And then that's a thing we need. We need to have the server address, and we get that from the host. So remember, we spin up our web app at a random port on our local host IP. So we want to pass our server address into to Playwright rather, so that it knows what the base URL are. So we don't have to specify that in all our tests. And we also tell it to ignore HTTP errors, because sometimes, like when you're running on localhost that I did just now, or click F5 in Visual Studio, it will spin up my web app, and it will use HTTPS and use the local .NET Dev Cert certificate that sort of makes that work. But that might not always be supported or trusted by the CI pipeline that you are running on that particular image. So this just tells Playwright to ignore any errors that you have there. And the next part is that we want to start a context. A context is sort of similar to creating a new browser profile. So you get a clean slate, like no cookies, nothing, or going into incognito mode, right? So you basically create a new context. And in there, we open up a new page, which is akin to opening a new tab in the browser. Now, all of that enables us to actually get to the actual test we want to write. So the first thing we do here is, let's go do this, is we say, well, I have my page, and I want to tell that page to go to this URL, the counter URL. So that's the relative URL for the counter page. And we have a little bit of extra source we need to pass here, because the counter page is it's a Blazor, not Blazor server, it's called interactive rendering now. So it's using interactive rendering, which means that you need to establish a signal connection between the backend and the JavaScript to work. And Playwright is fast, so if we just ask it to go to a page and then go straight to the next step, which is to find buttons on the page and click that, it might actually try to click the button before the signal connection has been established. So what we are telling Playwright here is to wait until there's no more negative traffic going on, which means that the signal connection has been established. There's other ways to do this that might be a bit more performant, because what it's essentially doing is it's just waiting 500 milliseconds and then testing and looking. So it's a bit slow to do that. You can also set something up where you listen for WebSocket connections being enabled, but that's a bit more convoluted and doesn't always work in all scenarios. But with that out of the way, now we can go to our page and say, get my button on the page that has the text click me, and then finally call click async on that. So that stimulates the user clicking the button on the page. Now, what we wanted to assert was that it now has the text current count equals 1. And we do that again by going to the page and say get by role and find the element that has the ARIA role of status. And we can quickly have a jump here to the component. And you will see that we have our p tag annotated with the ARIA role of status. So once we have that, we can use the Playwright specific assertions and tell it that we expect the status element to have the text that looks like this. Now, in terms of maintainability, there's a whole lot of things going on in this code that is not really specific to the individual test. So what I would suggest you do is that you refactor all of the stuff that we had up here into, a helper class, a helper type. And Playwright actually have a pattern they come with out of the box. They call it a page test, a type that you can inherit from. Here I've extended that ever so slightly, so I created my own Blazor page test that takes in the program, and program points to our program CS we have up here, which is the program, the host we want to run. And this basically does all the things we did before. It starts off the Blazor web application, and it does all the things with host name and servers. So we don't have to repeat that in all our tests. Now, another thing we don't want to repeat in all our tests is the logic we had with around waiting for a network connection to be stable. So there I've created a helper method called goToBlazor server page. So if you're creating a test for a Blazor WebAssembly app, you won't need that particular extension method. But this is generally a good approach to creating tests that are maintainable. Capture common patterns that you're gonna be reusing across your test and move them into extension methods so that sort of have a good strong name that indicates what's going on here. You could also imagine that if you had a Blazor app that requires authentication or required users to log in first, so before each test, you might actually have captured all the steps that you need to do to log in first. Like, so basically going to the root URL, then going to the /login and fill in some username and password that matches the test case you want to test. And then returns you back to where you came from, and then you can start your test. So capturing things like that in reusable methods that have domain language that matches your particular situation is a really good idea in testing in general, but specifically also here. And actually, I want to double click a bit on the whole get by role we have down here. So it's highly recommended in terms of maintainability that you try to go in and work with the elements in your web page in a similar way, as close to how the user would work with it. So when you try to find elements or try to do stuff with elements, try to target them on things that are visible to the user. So the user don't see if you have a div element or a span or an h1 element, but they see the text that are in there. And one of the tools that browsers have is ARIA attributes, where you can annotate different elements with ARIA attributes that indicates both to people that need assistive technologies, what kind of element of this, but also gives you more input to it. And that means that I can write a test like this where I say, I want to find something that has the ARIA role of button, and it should have this text. Now, if I go back to my counter component here and change this to be an anchor tag instead, this test will still work because, well, in this particular case, I would need to give it a role of button, but then it would still work. So I'm able to refactor implementation details about my code without my test breaking. And that's really a very, very important part of writing good tests, is that you can change implementation details without breaking your tests. Obviously, the reason why we don't need to have the role attribute on button is because some elements have default attributes assigned to them. So in this particular case, a button is by default, the ARIA role of button. So that is, a really good point to go through. And also, I found that writing Playwright tests like this, what ends up happening is that you almost, like, if you want to write a good test like that, you almost automatically enforces yourself to write proper accessibility into your web app. Like, you are adding the ARIA roles because that's what Playwright it almost forces you to go this direction. You could use query selector all to find elements in the page, but then you are very much tying a test to specific structure of your HTML, and that's probably not what you want. Okay. By the way, if you have any questions or comments, just shout at me. Otherwise, I'll just plow through these and you won't get a chance to interrupt me at all. So please do that. Now, I just want to showcase the tracing capabilities because I think they are super valuable, especially if typically for a Playwright test, like clicking a button and seeing that your output is there, it's like 3 lines of code. It's a very simple test. Typically, if you want to write tests for something, you probably have some more complexity in there. Maybe you have a complex form you want to fill out. You want to sort of simulate the user going through and filling out lots of fields. Those tests could be very large. It could be hard to understand what's going on. So tracing, you can do like this. So there is a context element that comes from Playwright where you can say start tracing, and I want to capture everything. I want to capture screenshots of the page. I want to capture snapshots of the DOM. I want to capture my code that was actually running during the test. So you can do all of that. And then you can see here the rest of the test is the same, but when the test is done, you tell it to, well, now I'm done with capturing the thing I'm interested in about this test. And this is sort of the place where you end up going to the command line if you're using Visual Studio. But here you can see there is, again, the Playwright PowerShell script. You can call show trace on that, and then you pass in the trace file that you generated. I've already done that, so let me just open that up here. Takes a little bit. Here we go. And you get this trace viewer that's built into Playwright. Actually, they have a trace viewer online as well. So if you, for example, running on your CI pipelines and you get the trace files captured and uploaded after the run, you can go and download the trace files and you can just view them directly in the online trace viewer. You don't have to use the local one here. And you can see here, we can see the flow of the test. There's a bunch of screenshots while the app is loading. And we have a timer up in the top. Then you have here each of the steps in the test that sort of was significant. So we have the go-to page where you can see we go to the page. Then the next step over here, you can see that highlighting that, it highlights what element did it click with a red square in the middle. And then finally we have our assertion where you can see it highlights this. And then there's other things. You can see the network traffic down here in each step. You can see console output, errors, logs, all of that. So it's a super valuable tool to have. Now, let me just double check my notes here. Yes, okay. So we talked about, I mentioned snapshot testing earlier, right? So we can use something called Verify. Verify is a fantastic tool built by a fellow called Simon Krupp. He has sort of the Verify base package, and then he extends that with a whole bunch of custom support for all sorts of things you want to snapshot. And snapshot means you basically take usually a big snapshot of some content. It could be an HTTP response, it could be an HTML page in our case, and you save that on disk. And then the next time you run your test, you take that snapshot you have and compare it to the output of the current test. And if they don't match up, typically using simple text diffing, then it will give you an error, and then you get a chance to update your snapshot if it's supposed to have changed. Otherwise, you capture it. And that can be useful if you have quite complex things, like if you are writing 10, 20 assert statements to sort of capture all the state you want, then snapshot testing can be really good. So in this particular case, we just want to capture a snapshot of the counter page again. We find the main part of the page. So the main part of the page has an ARIA role attached to it, saying this is the main part. And we get the HTML out of that, and we just pass that to Verify. And what Verify does is it will, by default, create a snapshot file. And you can see it's annotated with, let me zoom into that so you can see that a bit better. My zoom doesn't work. Here we go. It's annotated with the name of the test and then verified HTML in this particular case. Okay, allow me to zoom out again. There we go. And you can see in this particular case, it's just captured this because I asked it to just capture the main part of what I wanted. I could also capture the full HTML tag all the way to the end of the full page. Obviously, this can be a bit brittle because if you're building an app, you're capturing potential implementation details, like what are the elements I'm using. That might not be relevant in your particular case. So a better way that's been introduced recently with Playwright is ARIA snapshot. So here we have the same test, but the difference is this particular thing here, where you can ask Playwright to create a snapshot, and in line you can say, well, I expect that to be a structure that looks like this, where I have an ARIA type that is main, I have a heading which is the content of counter. I have a status of current count 1, and I have a button with click me. Now, again, this would support me going and changing, for example, the button type to an anchor tag instead. I could also say, well, it doesn't really matter that the heading tag is a level 1 tag. So if it doesn't matter to me that it's a level 1, I can just remove that and the test would still pass. So again, that's a way for us to capture potentially a quite big output. Maybe if you have a large form and you click save on that and you want to capture what is the state of the page, what is my output of my doing that action on my web page, I can capture that in a format that is quite effective at capturing the essence of what you wanted to achieve. So I definitely want to recommend using that compared to using just capturing the raw markup in this particular case. Now, let's see. Yes, so we have the weather forecast page. Another thing we might want to do is we want to test something that depends on services. In this particular case, we're going to the weather forecast page here, and we're finding the table. So if you remember, the weather forecast will load a table of elements, and we want to assert that I don't know what we want to assert necessarily about this, but in this particular case, we want to just check that, hey, we're getting five rows here. Now, and as you can see, it's quite straightforward. We go and say, give me all the table rows in the table body of the table, and we expect to have 5, and we got X amount of rows. Now, the challenge here is that if the backend that is delivering your API results, your weather forecast might not always return 5, right? So if you want to create a stable test, you probably want some way to control that if this is a particular test you want to write. Now, as I mentioned, with Web Application Factory, what you can do is you can go in and configure the actual app host before it starts running, so you can get control over it. So instead of our weather forecast repository that's built in and that is using perhaps live data somewhere from, we can have a stop or fake or mock version of that we use during testing. Now that takes away a bit from the complete end-to-endness of your test, so you lose a bit of, end-to-endness there, but then again, you also create an environment where your test will always do the same thing. So I've created a stop here, and I can specify how many weather forecasts should this run, should this return when it's called. So that means that I'm certain that this test won't change, it won't misbehave in the future if a dependency of mine changes. Now, let's see. Other things we want to talk about here now. Yeah, okay, so there's a few caveats to that, and that we want to be aware of. Let's see if we can get the slides up and going again. Yeah, there we go. So come on, there we go. So this doesn't work all the time. It works because our web app is hosted on the backend. But what if we were using WebAssembly? And with .NET 8 and Blazor.NET 8, we got the auto mode, right? So you can't change services on a WebAssembly app the same way that we're doing it here. So if we have a scenario where we have a Blazor web app and an API server, and we have our browser, and it's running Blazor server to get the weather forecast, and it will call there, which will have it call our weather DB repository, which will go to some data source. It could be a database or somewhere else where we have the weather forecast stored, and it will return it out. So that means that we can replace that during testing, right? But what if it's a WebAssembly app? Well, then it's probably an HTTP client that is calling our API, and it's calling this guy as well, and still our replacement work. But in the scenario where you're trying to replace a service that only exists on the client, maybe it's, I don't know, some authentication bits or something specific, or you're calling a complete external API, you don't have that hook that we saw here. We don't have that hook directly in our WebAssembly code. So there it's more black box testing in a sense. You don't have the same abilities as you have with the front end, but you can control your own API. So that's something to keep in mind. Now, that was sort of a whirlwind tour through what I think is the highlights of Playwright. There's lots of documentation that you can double click on and find ways to tweak and optimize that particular scenario you might be having. So component testing, that's the next topic. And for that, we're going to use bUnit, which was a library I created, I think 5 years ago now, and I'm maintaining with a couple of other MVPs today. bUnit is a library that allows you to test Blazor components in isolation. And it enables you to actually go and render a component, pass parameters to it, and get HTML out of it. Normally, like Blazor components themselves, they're just C# classes at the end of the day. But if you go and new one up, it doesn't know how to produce markup itself. It can only give you sort of it has a thing called a render tree inside it that represents the markup you want it to produce, but it doesn't actually know how to produce markup. So that's sort of what we get with bUnit. It doesn't care about the render mode that your component is written to. So if you are targeting interactive server, interactive WebAssembly, or just static Blazor, or maybe a new future render mode that might be coming out, we don't know, then it doesn't really matter. bUnit is in its own way, its own render mode. And it's sort of the goal we have is we want to make it so that it's easy for you guys to write tests that look similar to what you do with unit tests, right? So it shouldn't be too dissimilar. And many of the tools and practice and libraries that you use together with bUnit and your favorite testing framework, XUnit, NUnit, MSTest, or what is, I think TUnit is the new hot kit on the block, they will work together. And we also include some first-party services or doubles, test doubles for those. Like we have a fake navigation manager, we have a fake for authentication in Blazor, so that's easy to test scenarios like that. One thing that is sort of the key distinction, I think, between bUnit and Playwright is that bUnit doesn't run in a browser. It's all in C#. So you don't get your CSS tested, you don't get your JavaScript tested. So it's very much just testing the C# bits of your code. But we do have a specialized mock of the IGS runtime, and IGS runtime is the thing that we use to communicate with JavaScript from our C# code, so that you can still write assertions in your test that's saying that I expected this JavaScript method to be called from my C# library at this point in time, and you can yourself simulate JavaScript calling back to your C# components. You have all of that enabled and available to you. The upside of sort of only focusing on the C# parts of your Blazor component is that it runs very fast. And we have deep hooks into the Blazor runtime, so we know whenever there's a render cycle that's happening, so we can stop execution, we can allow your test to assert on the markup that's been produced and figure out what's going on. And the last point I want to highlight is sometimes debugging in Blazor can be a little bit tricky. And with bUnit, you just write a test where you set up the scenario and you can basically run your test, set your breakpoints, and step directly into the code. And that can save a bunch of times if you have, like compared to hitting F5, going into the browser, finding the right page where the component are, and start manipulating that, putting it into the state that you want to test. So if you don't like testing, at least you can use bUnit to debug your code with in Blazor. Now, bUnit and Playwright test can exist in the same test solution. So what we need to do is we just need to add the bUnit package to our testing project. And we also want to add bUnit's extension to verify to the testing package as well. So we can also use verify to snapshot bUnit specific things. So let's jump over to Visual Studio again. Let's see if we can get. I think that did it. Let's close all of these tabs. Let's undo that change. Now, up here in component testing, let's just start with the simple example we had before. So to be able to test our counter component again, see that when we click it, the type increments, we need to do this. So we need a couple of things. We need a bUnit test context. That is the thing that enables us to set up an environment we need to have around our components. So we can pass in services, we can call it, we can render it, we can pass parameters to it. The next thing we do is we actually ask our context to render our component. And this might look a bit odd because it looks like C# code, but we're actually in a Razor file. And that's a good thing because it allows us to easily pass in parameters, that's going to be examples of that later, to our component. Now, Razor files in a test project is not something you normally do, but the way you enable that is if you go to your test project and go to the CS proj file, the only thing you need to do is you need to change the SDK type to Microsoft.net.sdk.razor. And that enables the Blazor or Razor compiler to run and pick up your Razor files and turn them into C# files. And then all of a sudden you're able to write your C# Blazor files, you're able to write your bUnit test in Razor files. There is also, if you prefer, a syntax where you can just write it directly in C# code. And if anybody been working with the Razor editor in Visual Studio knows it's a bit finicky at times, so sometimes it might actually be easier to work with. But this is what we recommend doing. So out of the render method, we get a render fragment. And render fragment represents the output of a rendering of that particular component. So it has a bunch of things that we can do to it. One of the things it allows us to do is to search the DOM tree, the elements that were created by that component using a find method that is similar to query selector that you have in the browser, or if you use jQuery at some point, you would recognize that name for that method. And then we call the click method on the element we found, and that simulates, again, clicking that event handler that is, or clicking on the button, or in more precise terms, in bUnit, what we're doing is we're actually calling the event handler that is attached to the button in C# code. And now we do the exact same thing as we did before. We find the element with the role of status, and then we can assert that, count is 1. Obviously, there's much less things that are repeated here compared to the very vanilla Playwright test. We only have this line, but it's still recommended in sort of a bUnit test that you just, instead of having that instantiated in every test, you just inherit from that. And now all the methods, the render methods, other methods that are on the test context are just readily available to your test class directly. Otherwise, it's the same thing. Now, one of the things that we don't have yet to the same level of details as Playwright has are the find by role, find by, there's a whole bunch of find by or get by methods that comes within Playwright. That comes from a library called testing library. That's sort of the inspiration, and it's sort of a general way of addressing. So that's the semantic way or the more area-focused way of going in and finding elements. Typically, it's not a big deal because you're testing a component in isolation, but it is nice to have. So fellow MVP Scott Sauber started implementing the query APIs, the get by role, get by label, and so on and so forth in bUnit. And we have some of them now, and hopefully during the year we will get, especially the find by role will be implemented. It's a bit tricky, but it will certainly help a bit. Other than that, let's see, yes. Weather forecast test in bUnit is a bit different in that since we're not running the full server, right, we actually have, and if we go and have a look at the, let's see, weather page, you will notice that it's getting the repository, the source of the weather forecast injected into it. So when we're just rendering that weather forecast page directly, we want to enable bUnit to inject some service during testing. And in this particular case, you would recognize the pattern from many other places. We have a services collection on the test context, and that has an add singleton. And here we're just passing in the stop weather forecast repository. In this particular case, I decided that it should return true, and we can basically have the same test as we had before. Now, there's another interesting thing here, and that's the wait for elements. So if you remember, when you go to the weather forecast page, it shows a loading text, and then after, I think, 500 milliseconds, it will go and find the weather forecast. bUnit has the same ability to wait for things to show up so that your test remains stable. But what it does is, as mentioned, it does it a bit differently. Because we listen to the render cycle of the Blazor renderer, we know that when the task completes, that actually returns the weather forecast to the component and it updates the markup, the render will call back to the test and say, hey, I've rendered, so go and see if you can find the elements you were looking for. And it will block the rendering until that we've sort of done with that and we verified that we found the elements we have. So one of the problems that you can run into with Playwright is that if you have something where you are actively changing the markup, maybe in a loop every 100 milliseconds or so, you might wait for the change to happen, and then you start interrogating or working with those elements, and then it might change while you're doing that because Playwright can't block the browser from continuing to do its work, updating, getting new stuff. So we have much tighter control because we're directly basically providing our own render methods. Now, another thing that we can do is directly pass parameters to components that we want to test. So imagine that you are creating a component library, or you're creating reusable libraries or reusable components that you want to use multiple places in your Blazor application. So in this particular case, we have the alert component that we created, and we can just quickly show you how that looks like. It's a very standard alert component, not very interesting. If you work with Bootstrap at all, you would recognize some of the terminology here. It has three public properties, whether it's been dismissed, what kind of alert you want to create, and some child content. And that's sort of, created down here, following the prescription that Bootstrap gives us and how things should be looking. So here we can see how easy it is to basically set up a component under test, passing in just by declaring markup directly in our C#, saying, well, I want an alert component, I want these parameters being passed in with this child content. So that's a super easy way to actually set up a test scenario. And now, in this particular test, we're checking that we can dismiss things, and we can dismiss our component. And the end result after we dismissed our alert component by clicking the X is that we want to have the dismissed property on our alert component switch to true. So that's another thing we can do. So we start by doing the act. We actually dismissed the component, but now we can go into not just the DOM tree, but we can go into the component tree. So in Blazor, you have a tree of components that are actual C# objects living in memory. And in bUnit, we can go in and actually walk through that component tree. And in this particular case, we go from our component under test, which is our sort of top root of our component tree, and we say, find me a component of type alert. We know there's only going to be one because we only passed one in here. Once we have that, we get an iRendered component of alert type out, and that has an instance property on it that gives us the actual C# alert instance. And now I can go to my dismissed property on my alert component and ask whether or not you've switched to being true. So you can see we have this property, and when the button is clicked, we're supposed to switch that over to true. So we can sort of verify functionality. Now, again, discussion point might be, well, are we testing implementation details? Is whether or not a element has or component has switched its internal state to being dismissed or not? Is that something we want to have in our test? Probably if you're writing a component library, because then the dismissed property is part of the public API service that you're promising to your users of your component library. It might not be the case if it's just an internal component. So there might be some, it's not always a good idea. And it should certainly make you think a bit, especially if you're creating a web app. When you start interrogating the component tree, that might be considered an internal implementation detail of your web app, and you might not want to do this, but you have the option. Now, another thing I want to double click a bit on is working with markup. So in this particular case, we have the alert component, and it's a Bootstrap component. Bootstrap has CSS, and CSS expects us to produce markup that looks in a specific way, right? So normally I would say, well, it's not good idea to go and assert against a specific HTML markup because it might be considered an implementation detail. But we've gone to the Bootstrap website, and it's told us that, hey, you need to have markup that looks like this, otherwise our CSS will not work, right? So we want to make sure that if we go and refactor our alert component, that the Bootstrap CSS will still work correctly, and the alert component will still look correct. So this is where semantic comparison come in. So the problem is that if you just do a normal assert equals with two strings, well, there's many things that can change about an HTML snippet that will not make it, well, in this particular case, it won't break the Bootstrap CSS, but it will also not change the way that the alert component looks to the end user in the browser. So there's many things we can change about that. That doesn't really break it. And we don't want our test to break if we change the markup in a way that shouldn't really affect the usefulness of the component. So markup matches is bUnit's hook into the, it's a problem with the sliding mouse. It goes down to the corner. It's bUnit's hook into the AngleSharp diffing library that I created as well to be able to do this. And AngleSharp diffing is also used in the snapshot testing we saw before that Playwright is using for comparing markup. So how does it actually work? So let's look at an example here. If we go back to the alert component, just to make it a bit explicit. So this is the markup we created. Well, maybe we want to refactor this a bit. There's too much white space here, right? Or maybe we have a rule saying that, hey, all role attributes should be the first attribute on our elements in our code. Or maybe we want to sort of reformat it like this, right? This component will still result in the markup. It will still give us the same result to the end user, right? So our test should not fail. And with markup matches, and we can run the tests again, you will see that it still works because it's semantically the same, even though it's string-wise, comparison-wise, completely different. And the comparison we have, the semantic comparison works also by, it understands also that, for example, order of CSS class in the class attribute doesn't matter. So there's a whole bunch of advantages or knowledge built into the semantic comparer that enables us to do this kind of testing in a way that doesn't make our test break all the time when we are changing things or just hitting Control Shift F in our browser. So, and if we can take it one step further, if you want, for example, to capture all different combinations of inputs to your alert component, in this particular case, we can use data-driven testing. So here I have different kinds of input to my alert component, and I pass them in here. Obviously, this is sort of like inline snapshot, but we can also just pass our component under test to verify with the parameters that we used, and it will then do the same snapshotting with semantic comparison, and it will just spit out a whole bunch of snapshots, as you can see here, of each of the types of input. So then that gives you very strong protection against regressions in your code if you're building a component library and you want to not break your customers when you release a new version. Now, let me just double check I haven't missed anything about this. No. Back to slides. There we go. Okay, so again, quick tour through component testing. So now let's double click a bit on what it actually means to write valuable tests. And because there's no silver bullet, like we can't use bUnit for everything, or we can't use Playwright for anything, or in general, testing for that matter. You probably want to have multiple tools in your toolbelt to be able to get the most bang for your buck. So when you are creating tests, you are producing code, and code has, well, you have to maintain that, right? So you want to be deliberate about picking the right methodology. Now, for me, when I sort of look, not for Blazor testing, not just Blazor testing, but in general, when I look at what kind of approach I want to have to testing a specific solution, specific thing we're building, I sort of lean on these 4 pillars, properties for what I consider valuable tests. And the first thing is protection against regression. So I want my test to give me protection against regression. And the way the more protection against regression you get is very much dependent on how much of your application you're testing as a whole, right? So if you're testing all the way to the backend, including the database, all your external libraries, all the dependencies you have, you are protecting against quite a big scope of things that might go wrong. Obviously, you want to focus on the critical code that is, again, very specific to your use case scenario, but you might also be valuable to include third-party libraries, which happens implicitly in some cases, might also be valuable to include external dependencies or just out-of-process dependencies like databases, especially if the database is the implementation details specific to your solution. So the downside, or sort of the opposite of the is maintainability. The more complex your test setup is, the more dependencies you include in your test, the harder it's going to be to maintain that test. It's going to require more work up front to actually get up and running, and over time you remove dependencies, you connect to new endpoints, other things. You will need to update your test as well to support that if you're doing end-to-end testing versus specific isolated unit testing. So if you want your test to be easy to change, easy to understand, that might go against a wide protection against regressions. Another thing we want our test suite to be resistant to refactoring. So a refactoring of our production code means that we're changing an implementation detail, something that isn't changing the behavior, but we extract method, make the code cleaner, prettier, easier to work with. All of that should ideally result in you not having to change your test code. It might not always be that way, but in general, if you have a approach to writing tests, or you have a library that enables you to write tests in a way where you don't need to include implementation details in your test, then you're much more likely to get to that point. And the whole key is focus on externally observable behavior in your test versus internals. It can be super hard to avoid having any implementation details in your test, but it's sort of, that is the thing you want to aim for. And I think the fourth pillar is fast feedback, right? So when is it that we extract value out of our tests? It's when we run them, right? And if we're able to run them and run all our tests very fast, you're likely to run them more often. And so if you take the advice from Martin Fowler, he says that you want to make as small changes as possible, take small steps, run your test, then make small changes again and run your test. If you have test suite that takes a long time to run or breaks half the time, you're not going to be running it all the time. So you're going to make a bunch of changes to your code, maybe 1 hour, 2 hours into a refactoring session, and you run all your tests, and half of them break. And now you have, the only recourse you have is to open up the debugger and try to figure out why are the tests breaking. If you instead can have a very tight loop where you make a small change, you run all your tests, and if some tests break, well, you know probably where the problem is because you only changed a few lines of code in your production code, right? So there's really a lot of value in having very fast test feedback. So that's also very important to me when I'm sort of balancing whether or not to choose one technology versus another. Now, there's again no silver bullet because all of these 4 pillars are sort of in conflict with each other to some extent or another. But let's try and sort of create a scorecard for the 2 different approaches we saw, and hopefully that will give you an idea of what to pick, and we'll also discuss that. So in terms of protection against regressions, what are we thinking here? Well, I guess I should have used the red, green, and yellow stickers, but it's going to be low, medium, high in terms of protection against regressions. Anybody want to guess where our browser-driven test lands on that? So I want to say medium high, right? It's up to us still. Like if we can just run the web app and we can go, if you use web application factory, we can go and remove all dependencies more or less. So it's only the produced markup. That gives us less, but we have potential to go completely end to end with Playwright, which has quite a bit of value. Component testing, I'm going to say low to medium. Again, there's nothing preventing you from injecting all the services that call the real APIs when you're testing a component. You probably not want to do that, right? That's a different scenario. So refactoring, protection against refactoring production code. Again, Playwright, it forces you into a pattern where you can only look at what is externally observable. And by interacting with the component using ARIA attributes and other things. So it's likely going to be high. With that caveat, though, that when you add new things, or if you change things that is not a refactoring, well, you're going to have challenges. We will get to that in the maintainability. Here, that will also be high because you're isolating and testing things in isolation, and you can sort of set that up in a way. So, if again, following the same practices we've seen in bUnit as well, you get the same leverage, the same ability to just query for specific public-facing things. Obviously, it depends on the scenario, but you still have that ability. Feedback, well, I'm going to give it a low for browser-based testing because it does take longer to run. I'm not saying Playwright is slow. It's comparatively fast to its predecessors, but a Playwright test will run maybe in seconds. Sometimes you can get down to half a second, milliseconds even, but on average it's maybe a second or so. Obviously it takes a bit of time to spin up everything, but it's going, it's pretty fast. If you have animations on the page, if you have like a slider that comes out, it takes half a second to animate that. Well, Playwright has to wait half a second for that to animate finish before it can start clicking buttons in it. So typically they're a bit slower. bUnit is comparatively very fast, right? It's like a unit test, right? So individual test will take milliseconds to run. Maintainability, and that's sort of, and this is not necessarily a critique of Playwright, or it's more in general for end-to-end testing, you have more moving parts, you have more things to maintain. So if you change functionality, you probably have a lot more places you need to go and update. You can compensate a lot for that by having reusable methods and other things in our code. But at the end of the day, you've got to have more code, which means more maintainability. And bUnit will probably have a high there. Again, depending on, it's up to you, but you can definitely, it's easier to get to that point, I would say. Now, to answer the question, what should I pick then? Anybody disagree with this assessment sort of on average? I'm not saying I have all the right answers here, but okay, I don't see any protests, so let's continue. So let's look at different scenarios. What should I pick? So if I'm building like a form over data, right? Classic apps that many of us have probably built, we have some sort of internal business application. I would probably go with end-to-end testing or browser-based testing, because you're not likely to have a lot of reusable components in your code. And it's relatively easy to get going with Playwright. So if you are able to actually go into that scenario where you can spin up your application easily using maybe Aspire, then probably go with that. And you will have a good protection against regression. You will have good value out of your test. And you probably won't have that many tests, so maintainability is not really an issue. If you have more complex apps, or if you use, maybe there's a good amount of reusability in there. Maybe you, like a large app, will typically have dedicated components that are that you use in multiple different pages, for example. Then I would probably just have a mix of both, right? Especially if you have complex components that you're reusing across different pages. So that would be good to sort of use both and do that. If you're just building a component library, there's definitely our friends at Telerex outside, they have a Blazor component library. Lots of other teams have component libraries. They're using bUnit quite heavily because that allowed them to test their components in isolation. And that is their public surface, right? The individual components is what's being used by the end user. So they don't think about their full suite of components. So there you would probably lean on that. But if you have a lot of JavaScript, that's sort of the caveat there, because bUnit doesn't run CSS, doesn't run JavaScript. So, and I think my go-to example is actually the Blazor team. For the Blazor server project, they have a whole bunch of complex JavaScript that sort of sits on one side in the browser and receives updates from the backend. So they use, last I checked, they actually use Selenium, but they might have upgraded to Playwright. But because they need, the point of that test is to test that the integration between the C# code and the front-end code works very well. So they have a lot of complexity they want to test end-to-end. But in many cases, you can actually get very far with just using bUnit, if that's your scenario. Okay, I think I have 2-3 minutes left, so if there's any questions, now's the time, otherwise come and find me after. The demo code is all up here, and as you can see, the last commit was 2 hours ago, so it's very fresh, and it works. And there's also a pipeline YAML file, so you can see how to actually run Playwright test and do the snapshot things and uploading those and getting that as well. And you can find me here at the conference or find me on the socials if you have any questions or want to connect afterwards. Okay, that's it. Any questions? Okay, you are dismissed. Oh, remember to like and subscribe on the way out, right? I think that's what you're supposed to say.